Assalamu alaikum. I am Osama Muhammad Shabaki, BKG student, section 2. Our group members Abdulaziz and Omar and Abdullah. I am going to talk about introduction to electronic communication system. In the first, the definition of communication system is a system model that describes a communication exchange between two station, transmitter, or receiver. The aims of communication system is to transfer information from one place to another. Electronic communication can be described as a transmission, reception, and processing of information between two or more locations using electronic circuit or device. We have here basic communication model. Basic communication model show the communication flows between 2 points. Signal or information passed from source to destination through what is called the channel, and after that, which represents a way that signal used it to move from source toward destination. So we can define source as sender of the information or transmitter, and the channel is transmission path of the information between the source and the thing. And we have here a extensive way of the model for a communication system. We have transmission channel. It's a physical link between the communication parties. And we have a modulator. It's transformed the source signal so that it's physically suitable for the transmission channel. And we have transmitter. It's used to introduce the modulated signal into the channel. And we have also the receiver. It's used to detect the signal on the channel and amplify it. The last one is we have demodulator. It's used to get the source signal. The original one is from the received signal and pass it to the recipient. The power measurement. Magnitude of communication signals span a very wide range, causing an error as following: extremely large scale and hard calculation, and prone to errors. The last one is hard to compare the signals, and we can use logarithmic scale as a solution. The dB value is for the power here, so we have B1 which represents to the reference power B2, and the dB value showed the difference in dB between power B1 and B2. There are two types of nonlinear distortion. The first one is harmonic distortion. It happens when unwanted harmonic of a signal are produced through nonlinear amplification. And the second type is intermodulation distortion. Intermodulation distortion is the generation of unwanted sum and difference frequencies produced when two or more signals mix in nonlinear device. Electromagnetic frequency spectrum. Communicating the information between two or more locations is done by converting the original information into electromagnetic energy, and then it will transmitting it to the received where it's converted back to the original information. The electromagnetic energy is distributed throughout infinite range, and we have here an example of total electromagnetic frequency as shown below. The wavelength is the length that one cycle of electromagnetic wave occupies in space, and we can represent the wavelength as this equation: lambda equal to c over f, where lambda is wavelength and c is the velocity of light, and we have here the constant value of velocity light, and f is represented as frequency. And we have also here the example of total electromagnetic wavelength spectrum as shown below.
Assalamu alaikum wa rahmatullah. My name is Abdullah Bassam Abu Asif from FKE BAKG student, section 1. I'm going to continue to explain chapter 1, Introduction to Electronic Communication, part 2. Noise representation types and source. Definition: any undesirable electrical energy that falls within the passband of the signal. Effect of noise on the electrical signal. Two general categories of noise: correlated noise, noise that exists only when a signal is present; uncorrelated noise, noise that is present all the time whether there is a signal or not. Uncorrelated noise. Two general categories of uncorrelated noise: external noise and internal noise. External noise. Number 1. Noise that's generated outside the device or circuit. Atmosphere noise. Naturally occurring electrical disturbance that originate within Earth's atmosphere, such as lightning. 2. Also known as static electricity. Extraterrestrial noise consists of electrical signal that originate from outside Earth's atmosphere, and therefore also known as deep space noise. Categories of extraterrestrial noise is solar noise, noise that generated directly from the sun's heat. Cosmic noise, blackbody noise, noise that is distributed throughout the galaxies. The law N equal K multiply T multiply B, where N noise power and unit watts, B bandwidth unit hertz, T absolute temperatures unit Kelvin, T equal Kelvin plus 273 degree, K Boltzmann's proportionality constant 1.38 multiply 10 minus 23 joules per Kelvin. Next, thermal random noise, equivalent circuit for a thermal noise source when the internal resistance of the source Ri is in series with the RMS noise voltage Vn. Harmonic distortion occurs when unwanted harmonics of a signal are produced through nonlinear amplification. Distortion measurement. Correlated noise, harmonic distortion. Distortion measurements. Net harmonic distortion equal ratio of the RMS amplitude of net harmonic to the RMS amplitude of the fundamental. Total harmonic distortion THD in present equal V higher divided by V fundamental multiply 100, where V higher equal root V square 2 plus V square 3 plus V square n, all in RMS value. Noise factor and noise figure. Noise figure in ideal and non-ideal amplifiers. As shown here, signal power N, noise power N, mean input, equal ideal noiseless amplifier, equal power gain. Signal power output divided by noise power output equal to A multiply S divided by A multiply N equal to S divided by N. In reality, amplifiers are not idle, adds internally generated noise to the waveform, reducing the overall signal-to-noise ratio. Noise factor and noise figure. Noise figure in ideal and non-ideal amplifiers continue. In figure B, the circuit adds internally generated noise ND to the waveform casing the output signal to noise ratio to be less than the input signal to noise ratio. And last, noise factor and noise figure. Noise figure in cascaded amplifier. As shown here, input is divided by N dB to amplifier 1, amplifier 2, amplifier 3, output will be S divided by N, output equal to S input divided by N input NF.